go into the pH now. Another component that's important. Determined by diet. Remember, if it's uric acid, which is what? What does that mean to you biochemically? What's uric acid mean? Breakdown of purines. Good. You've heard of the purine salvage pathway. And uric acid may accumulate in your urine. How often do cells break down? Cells break down all the time. Do cells contain DNA? Of course they do. And what is DNA composed of? Purines and pyrimidines. You break down your purine, what are you going to release? Uric acid. And if it ends up in your urine, what's your pH? Decreased. Correct? Uric acid, decreased urinary pH. Keep that in mind. Now, determined by diet and acid-base status of the patient. I just gave you one. For example, pure vegan or vegan. Who's your patient here? In the United States, maybe perhaps more along the lines of California and such. Doesn't have to be, but just saying. In terms of vegan communities. And these individuals are doing what? Well, they're not consuming any meat. There's a difference between vegetarians and vegans. Vegans don't even consume dairy products. Now, that becomes a big deal for us pathologically because vegans in developed countries might actually develop over a number of years known as B12 deficiency, So there's certain things that you want to keep in mind. But for now, pure vegan usually have what kind of pH? Alkaline. The citrate is converted into bicarb. What's bicarb mean to you? An increased pH, alkaline. What about meat eaters, carnivores? Usually have a acid pH because of organic acids in the meat. Simple example of diet and as to how that will influence the pH of the urine. What if it was alkaline? This would be ammonia perhaps. So here, if you are thinking about urinary tract infection and you have an alkaline organism such as Proteus, then please understand that some of this urease is then going to take your urea and convert it into ammonia. What is that going to do to your pH? It'll then alkalinize it. Let's move on to protein being a component of urine analysis. Detects albumin. Big time importance and differentiation from globulins. Now globulins, perhaps, may or may not get through. Let's not focus our time on that. Let's focus on albumin. Let's say, for example, that you have diabetic nephropathy. And we'll talk further about this later on. And one of the first signs that you find with diabetic nephropathy is going to be that you find microalbuminuria. And you will use a specific dipstick so that you can find this. And that to you should mean automatic glomerular damage. Now, there's something called sulfosalicylic acid. And this is going to be, pay attention here, SSA. At least keep in mind, salicylic acid. Salicylic acid, which is part of this SSA test, specifically for protein. What kind of protein? You've heard of BJ proteins, Ben-Jones proteins, have you not? As soon as you hear Ben-Jones proteins, then what are you thinking about immunoglobulin? Light chains. What's that mean to you? Kappa lambda, kappa lambda, kappa lambda, right? What does that mean to you? Well, you know, you've done immunology. If you haven't, you will. And when you do, you've dissected the anatomy of an immunoglobulin. An immunoglobulin is made up of a heavy chain and light chains. You've heard of constant and variable regions. Now, forget about all that. Let's keep it simple pathology. The light chains are kappa and lambda. If it's something like multiple myeloma, what are you going to release? Pay attention. In multiple myeloma, what are you going to release? IgG, IgA, no IgM, IgG, IgA, and then this then releases your light chains into where? Maybe perhaps starts accumulating on the glomerulus and maybe passes through. My point is this, that's a globulin, isn't it? So therefore SSA would be specific for detecting globulin. That's very important that you understand this because you want to order the correct test for the correct component that you're suspecting based on the history of your patient. What's your history of patient multiple myeloma? Bone disease? Sure. What kind of bone disease? Lytic bone lesions, punched out lesions, correct? So that type of history will only help you then supplement your information. Albuminuria, reagent strep and SSA have the same results. So that as far as SSA is concerned, that will help you more so with the globulin, whereas the albumin dipstick is only going to look for albumin. Examples, diabetic nephropathy, and then of course we'll get into later on our glomerulonephritis. Now if it is Benz-Jones proteins, that's what BJ stands for, Benz-Jones proteins, then your SSA greater than reagent strip test. Always confirm BJ protein with urine immunoelectrophoresis. Is that clear? So you're always going to confirm your Bence-Jones proteins with immunoelectrophoresis. And at that point, when you use a particular stain, known as Congo red stain, what are you going to find? Apple green birefringence, aren't you? Because this is amyloid. Are we clear? We're putting in a lot of information, but you must be able to put things together so that you come up with the proper diagnosis. Spend a little bit of time here with protein component of your urine.